Hello. Today we are exploring a specific subclass of first-order differential equations that can be solved using direct integration. By the end of this lesson, you will be able to identify separable equations and apply a step-by-step method to find their solutions. A first-order differential equation can often be expressed in this general form. This is our starting point, where m and n are functions of both x and y. Now, let's look at a special case. What happens if the function m depends only on x and the function n depends only on y? When this happens, our equation simplifies significantly. This specific structure is what we call a separable equation. It is called separable because the variables x and y are already effectively isolated from each other in their respective terms. To solve an equation in this form, our goal is to get all the y terms on one side and all the x terms on the other. We do this by subtracting m of x dx from both sides. Now that the variables are separated, we can perform direct integration on both sides of the equation. We integrate the left side with respect to y and the right side with respect to x. This process will yield a general solution for the differential equation. Let's apply this theory to a concrete example to see how the mechanics work in practice. Consider the equation x dx plus y dy equals 0. First, let's check if it's separable. The term with dx contains only x, and the term with dy contains only y. Yes, it fits our definition perfectly. Following our method, we move the x term to the right side by subtracting it from both sides. We now have y dy equals negative x dx. Next, we apply the integral to both sides. The integral of y with respect to y is y squared over 2. The integral of negative x with respect to x is negative x squared over 2. And of course, we must include a constant of integration, which we will call c. If we move the x term back to the left, we get x squared over 2 plus y squared over 2 equals c. By multiplying the entire equation by 2, we can write it as x squared plus y squared equals k, where k is just another constant. Notice how this describes a family of circles centered at the origin. We have successfully found the general solution. Let's summarize what we have covered today. We began by defining the standard form for first-order differential equations. We learned that an equation is separable if the variables can be isolated, specifically when the equation can be written as. We then demonstrated this with a worked example, showing that the solution involves integrating the left side with respect to y and the right side with respect to x. You are now equipped to handle these types of first-order equations. Take a moment to think about how this method relies entirely on your ability to integrate the functions m and n. If you can integrate them, you can solve the differential equation. Thank you for joining this lesson. Keep practicing these steps, and I will see you in the next session.